I'd like to welcome everyone to ClimaCon 2022. My name is Matt Rollison. I am the Director of Global Sales for our Energy Division. I'm here with Dip Patel, CTO and co-founder of Soluna. We're going to be talking about making renewables more sustainable, recapturing wasted energy for computing innovations. So, Dip, I'd love to hear a little bit more about yourself. If you would be able to go through your background, how you ended up in this space, and we can jump in from there if that works.
So I started in Kenya. That's where I was born. I'm an immigrant. So I came to America, and the number one thing was always risk aversion, right? Build your base, right? Make sure that you can survive. So a lot of the jobs I had were always like that. And when I went into high school and college, I started focusing on careers that were represented these stable bases. And of course, doctors are the number one that everyone talks about. But I chose engineering because I was more math inclined than biology and chemistry. And I picked electrical engineering because at the time, wireless technologies were just taking off. And I remember when I came to America and I saw my first remote control car that didn't have a wire, right? And I was like, what in the world is going on here, right? And so I said, I got to get into wireless. So I focused on electrical engineering. And when I graduated, I went into the defense industry. And the reason is a lot of my family's in the armed forces or in the military or somewhat in the government. And I lacked the courage to directly do it, unfortunately. And, so I went and built tools that they use. And I went to Lockheed, and my whole career was focused on radar, electrical warfare, and wireless technologies. And electrical warfare is basically using electrical energy to confuse or protect yourself. So confuse the enemy or protect yourself. So I've focused a lot on electrical, RF, radar, and what I realized at Lockheed was if I left the defense industry, the defense of the country would be fine, but energy was scaring the hell out of me. And if I look at energy, and this was back in 2008, 2009, a lot of people were focused on the generation of energy and the storage of energy, but no one was focused on buildings and how to make them better. And every building I'd ever been in had this problem where some rooms were too hot and others were too cold. And it would just, is the window leaking? Is there insulation? Is the air conditioner bad? You have no idea. So I went to MIT to start a company to solve that problem. And I did that. It was called EcoVent. And the idea was we can make the house comfortable by moving the air around to keep it temperature right. But also we created an X-ray for the house where we could basically tell you whether a room had bad insulation or a blocked duct. And so we built this company. And the reason that company was the one that was important, again, it was always about energy and a problem that was ignored. So that's how EcoVent was formed. It was looking at the building. Now, that company, we sold it, and I was trying to figure out what to do next. And I'd always been interested in cryptocurrencies, actually. I used to mine Bitcoin on GPUs and CPUs back at Lockheed. And so I was always into it. And while I was selling EcoVent, and running EcoVent, there was a CEO forum that I was in. And in this forum, I met with other CEOs and we got to know each other. And John Belizaire was one of these CEOs. And he was a guy that I just, from the bottom of my soul, respected and admired. And so I got an email one day from John, and the email said, who do you know that knows about crypto? This is the subject line, okay, comma, I need a CTO. I didn't even click the email. I just called him. I said, yo, I'm not introducing you to anybody. Whatever you're doing, I want to get involved, right? And I'm into crypto, so I might actually be a good fit. And so it was a joke, but we started talking, and he said, look, in Morocco, there's this huge wind farm that is dealing with a huge amount of curtailment, and they can't get connected to the grid. And we're going to try and find a way to make that work. And I said, I'm in. And the concept was to connect Bitcoin mining, right? This private equity shop. But what made it very interesting to me was not only was it solving a major problem in energy, but one that was highly ignored, curtailment, and one that was uniquely, in my opinion, suited to what I built at Lockheed, right?
Mm-hmm.
People are like, what are you talking about? Well, if you think about what I built at Lockheed, what they were was radar systems that were deployed in the middle of nowhere. They needed to be highly complicated, but very automated. And they needed to be exceptionally efficient, right? Because the more efficient a radar system, the farther I can see, the longer I can see. So the way my engineering brain and culture had been molded was perfectly suited for building a data center in Morocco.
Mm-hmm.
But here's what made it really interesting. You needed to build a data center that can vary how much power it consumed. And nobody really knew how to do that. And nobody even understood how to do that or even thought it could be done when we started this company. But if you look at a radar, they're designed to turn on and off rapidly.
Mm-hmm.
So I couldn't understand why it hadn't been done. And that's how I ended up here, right? I went through the interview process and, of course, John wanted me, but that's never going to be enough. And, we went through a lot and here we are. And it's been great. And I'm very lucky to be in the position I am. And thank you, Johnny, for bringing me in.
That's a fantastic answer and a great segue into the next question here. So what is Soluna? Like, where did the concept originate? Was this through John? Was this through another idea? Like, what sparked the interest in it? How did you guys get here today?
Well, it's a bunch of pivots, right? Mm-hmm. So it really started with this concept of this massive wind farm in Morocco that literally, if you built it, would break records, right? Mm-hmm. But it's not getting built. And it had 8 years of engineering done on it, but it still couldn't get built. And it's because there was no grid connection, right? Mm-hmm. And so if we can connect the grid or use the energy before the grid comes out, then the investors will build a wind farm. This was the thesis, right? And then once the grid shows up, you disconnect the computers, you hook up the grid, and everybody's happy. And now all these wind farms and green energy sites that have been sitting waiting for grid can no longer, right, have to wait. And what happened was we're working in Morocco, this model's coming along, and COVID hit, right? And it basically hit the brakes on Morocco, but it also gave us a sense to just take a deep breath and realize, okay, this problem exists in Morocco and our business model is to build the wind farm plus the data center. But really the magic is in the data center, right? The wind farm, we're going to hire people to come build it. There's nothing really unique about it. Just the thing that's unique about it is connected to a data center that can consume this energy that the grid can't accept, right? And so we said, let's call green energy sites in America and see what the problems they're dealing with are. And this is what we teach at school too, which is call the customer and find out what the pain is. Don't assume, right? And we call them. Curtailment was always the first pain point, which it should be because physics dictates it's still a problem whether you're in Morocco or America. Mm-hmm. And weather's the same way, right? Math is math, right? That's the beauty of it. And basically we said, well, what if we could build a data center that could consume only this extra energy? And they said, you can't. Data centers are base load, right? They consume stable loads. They need clean power. They need redundant power, all this stuff. And we said, no, that's that data center, not our data center. And all of a sudden, the data center became a product that solved a problem that is a huge problem in green energy. And it solves a problem on the compute side, which is people are generating petabytes of data. It needs to be processed. And it's currently being processed in data centers designed for real time, YouTube, Zoom, right? These aren't data centers designed for processing large amounts of data. So when you build a data center that's designed for processing the large amounts of data, looks a lot like a radar system, right? And you can make it cycle its power. So it all of a sudden becomes a perfect fit for this problem. And that's where Soluna is now and what we are. We consume wasted energy that nobody else can consume.
I love it. I love it. So can you tell me more about the concept of wasted energy, right? Like you mentioned it a few times there when we're talking about it. Like what are the big concerns that you have here for for wasted energy on the on the market, right? Like these big asset owners are creating, whether it's a wind, solar farm, hydro, and then 30% is going to waste. Like, what are your thoughts on that? Why has that not been solved up until now?
Okay, that's a great question. So you nailed it, right? Imagine I'm a business owner, and before I sell my product, somebody takes 30%,
Mhm.
right? And that somebody is physics.
Mhm.
And what's happening that I've seen is wind farms and solar plants that exist have to be made smaller
Mhm.
because the grid, which is where they plug into, right? The grid serves the people.
Mhm.
And when I turn on my light, it better turn on, right?
Mhm.
And so the grid is like, all right, no matter what, we have to supply enough energy for the people. And the people are selfish. No offense, but people are selfish, and that's okay, right? We have to serve, we have to use that selfishness as the catalyst, right? So people want energy, they want more compute. So this demand for energy is going through the roof. But yet every time we make a wind farm, 30% of the energy is gone. So as a financier, as a business person, I'm like, wait a minute, 30% of what I do is gone. I could have the best engineers and they're down by 30%. The best finance down by 30%. So why hasn't this problem been solved? Well, it's a lot of energy,
Mhm.
right? And so batteries have been starting to be developed, but batteries aren't perfectly efficient. And in my opinion, they're a band-aid. They just store the energy until the grid can accept it. But the thing is, if you use a computer and the demand for this computer is going through the roof, what happens is the number one problem in green energy is not curtailment is the number one problem, but the problem that is leading to, or the curtailment is leading to, is what they call like a queue in grid integration, right? So let's say I could build this incredible wind farm and everybody will make energy and the communities want it and everything. It might take me 15 years to get it built because the grid itself can't act, I can't plug into it because it's full. But the beauty is it's only full for like 10% of the time. And then the rest of the time, it's like, what do we do? And the wind farms peak in midnight, right?
Mhm.
So it's midnight, everyone's asleep. What do I do with this energy?
Yeah.
Oil I can store, right? So we're building batteries, and batteries are great, but the answer is to just consume it, just eat
Mhm.
it, eat the extra and serve the people what they need and consume the extra. And what it'll do is allow us now to not only integrate all of these wind farms and solar farms that are waiting, the money's waiting, the contracts are there, they just can't connect, right?
Mhm.
So they get unlocked. But here's the magic: you can make them 10 times bigger, and the beauty is places that have abundant green energy but have no consumption, like any island within the tropics, right? Tons of energy, but no people. So you can't consume it all. They can all of a sudden just put a massive data center on site, make a
Mhm.
huge green energy site. Now, these countries that spend all their money importing oil can finally get independence and they can thrive. And as a person from Africa, to see that and have a chance of influencing that, I'm down. I'm down. I'm ready to go. Right. So that's hope. That's the world we're aiming for, right? Unlimited green energy that has been effectively financed by the insatiable thirst of compute
Mhm.
that we have as humans. Right. It's
Mhm.
beautiful.
No, totally agree. And so, can you talk me through some of the projects that you've done to date? I know there's, as you mentioned, the one in Morocco, but you mentioned that you're also working here in North America. So,
Right.
are you focused on green or brownfield projects? I also know that you have a unique way of naming these projects. So, keen to hear a little bit more about that.
Oh, I love that. Yeah. So, we name our projects after what we call badass catalyzer women. These are people that just know. How many people have heard of Sophie Wilson, right? And maybe 3 out of 10 will raise their hand. You see how many people have heard of Elon Musk or Steve Jobs, and they'll all raise their hand, right? And Sophie Wilson invented the architecture that enables this mobile revolution. The entire thing is
Mhm.
due to ARM architecture. It came out of her brain and her team, of course. I'm not giving her full credit, but the fact that nobody knows who she is irksome.
Mhm.
I have 6 sisters that I grew up with, and my first baby's a girl, so it's the magic here is to just bring light to people that deserve it. And um, you know, we have a couple of sites in the United States, and two of them are quote unquote brownfield, right? They
Mhm,
existed, and we retrofitted them into our model.
mhm,
And one of them is greenfield, which
mhm,
is beautiful because that one is um, a site that was designed working with the utility that was dealing with the problem, right? So the utility had a problem. We worked out a contract. We got land from the utility. The utility actually connected us to the substation, did all the grid studies. So it was a very symbiotic, incredible relationship
mhm.
that proves that this can exist. And that's running, and it's Project Sophie Wilson,
Love
and
it.
it's amazing, and I love it. And then we've got Project Edith in Washington State, and Project Marie in Kentucky as well. And we've got new projects coming up in Texas
Mhm.
this year as well. That'll be named after Project Kati, and after the beautiful inventor of mRNA. And
Mhm.
we've got Project Rosa as well coming up. On the heels of that. So there's these projects that are coming, and you'll hear more about those as we build them.
Fantastic. And I know Soluna is heavily focused on creating technical jobs that transform local communities as part of these projects. Can you elaborate a bit more on that for us?
Yeah, so we always joke that the systems we built at Lockheed had to be like serviced and maintained by soldiers with very little training,
Mhm.
in a very stressful environment. And how can we build data centers that do the same thing? If you look at existing data centers, you do have a lot of people that aren't highly trained, but they're usually not interesting jobs. They're just walking around looking at status. And the really tough work is by people who have a high degree of training, in takes a long time to earn these trainings, and not everybody has the resources to learn. Not that they don't have the capacity, they just don't have the resources. So our concept is we train people, we bring them in, they don't need a college education, and we've built an operating system around to support not only teaching them how to run the site, but then they can become the teachers, right?
Mhm.
So what we like to do is bring local people in to run the sites, to hire new people and train them, and kind of we go in, and then what we've got is a remote support architecture very similar to the U.S. Navy and the DoD, that when these sites have problems that they're not used to, they're not afraid. They have
Mhm.
like, they can call, and they call us at the highly technical support center, and that's where we can really do things that they may not be trained up in. But what's awesome is once we learn it, now the training changes, right? So it's this beautiful system that enables people to learn technical skills. And once you're trained up at a Soluna data center, blockchain, networking,
Mhm.
mining, GPU,
Mhm.
AI, ML, you now can become hired anywhere in the world, right? And that's our goal, is to like, let these folks grow within Soluna, but also let them achieve dreams, in other jobs, and
Mhm.
continue to just keep that organism and that kind of like root system going, so
Mhm.
we can just help these communities that just have down on their luck, right?
Yeah, yeah, definitely. No, I totally agree. And so Soluna has recently gone public. So I'm really interested to hear a little bit more about that. What prompted that move, and where's that investment going over the next 2 to 5 years? Like, what does the future hold for Soluna?
Yeah, thank you. So I am not a financier, so to speak. I know enough of it to understand the conversations, but I am not an expert. So please keep that in mind as you
Mhm.
hear what I'm saying. When you're building a company like ours, one of the most important thing is to have around you resilient capital, but also cheap capital, money that is not super expensive to have. And that's very hard to do when you are a quote unquote startup, because you don't have a lot of social proof yet. We don't have gigawatts of data centers running, right? So what we have to do is execute, grow slowly, and show that we have this capability, and then the investment comes. So the concept of going public and the purpose of it was to enable Soluna to gain access to capital that is at the scale, but also the risk that we need to match the company's growth, right? And so, you know, if our goal was to grow at a certain rate, we might have just stayed with VC and
Mhm.
stayed private, or even bootstrapped using our growth. That's another thing we could have done. But there's a massive I am way too impatient. John's way too impatient. Phil and Larby are too, and the world is dying. Like,
Yeah.
let me make this abundantly clear to people. The world is dying. Every model that's out there, my I'm actually afraid that they're conservative, because the truth is scarier. And
Mhm.
biodiversity is going away. We have no idea how to get biodiversity back, right? So there's so many things that are dying, and we can't get them back. And if we don't do drastic shit quickly, we're in trouble. And if we don't find a way to do it quickly, but also make people money, it's never going to happen, because you have to make people money. And so going public allows us to not only get access to that capital, but it enables us to be very public about what we're doing, and transparent. And it enables us to also build a base of very strong investors that come in and provide that resilient capital.
Mhm.
So you've got the resilient capital that comes in through banks and through infrastructure funds. And then you've got the transparency in our business model that enables other equity investors who understand what we're building and who really believe in it to now invest as well. And
Mhm.
so that's how I understand it. You know, there's a lot more nuance, you know, but the way I see it is we've got a lot of money to raise, and a lot of
Mhm.
the money we're raising is not in R&D. There's a decent amount that goes into engineering, you know, and technology, but
Mhm.
it's also for building data centers,
Yeah.
connecting to, you know, buying power equipment. This is
Mhm.
stuff that is not quote unquote high risk and
Mhm.
has a high degree of value. So it enables us to kind of build this hybrid approach. And we're a very transparent company by our nature. So the reporting and all of that wasn't a cultural shift. It's a mechanical shift, because it's a lot more stringent how you do reporting, but
Mhm.
it fit us culturally. And
Yeah.
so,
Yeah,
you know,
no, it makes total sense. And so you mentioned, you know, the need to accelerate this quickly due to climate change, right? We both know that climate change is heavily impacting the energy industry. So can you talk a little bit more about how weather impacts the day-to-day operations of these data centers, right from development through construction through operations? How is that impacting what you guys are doing and thinking about on the daily basis?
it's a huge thing. But here's the interesting part, right? It's about measurement, right? Until you measure the performance of a data center, you don't necessarily know how much the weather impacts you, right?
Mm.
But again, we come from our DNA is of measurement and working for the DoD, where you have to foresee problems, right? And so we built these systems to measure what's going on at our facilities. And I could tell you the weather is massive, right? Even the wind direction can have a massive impact on your airflow within a data center. Our data centers are designed to have record breaking, what they call PUE. That's a measure of efficiency. And we are the most, from what I've seen published, we're the most efficient. But, you know, when you look, you can see that number start to fluctuate based on wind direction, right? You can, another example was when we had those huge wildfires in like Oregon, right? The smoke and the particles, we actually saw a performance degradation in a data center a couple hundred miles away because of those particulates in the air clogged our filters faster, right? So weather is highly important, but because it's not the most important thing right now, it's not heavily looked at least in the space that we're in,
Mhm.
right? But as the other efficiencies get worked out, people are going to start paying a lot more attention to the weather. And what we've seen is weather has a big impact, and it's something that we pay close attention to. And we've got partnerships with companies to give us high fidelity data so we can make good decisions. And not real time yet. We're not doing real time. This is historicals, but
Yeah.
you know, now that helped design the initial data center. Now
Mhm.
we're working on the real time stuff to actively manage our data center based on what's happening. Right.
Yeah, totally understand. So, you mentioned a couple of key things there: wind direction, speed, wildfire particles. So how would a weather intelligence platform help you to streamline decision makings around this, right? So if there is a wildfire in the area and there are going to be particles, how would streamlining decisions around that be beneficial for Soluna and these data centers?
Well, I mean, there's well, just knowing that it's happening
Mm,
enables you to act in a very, let's just say, rudimentary way. I could shut the site down and put louvers
mm,
down. Let's say
mm,
there's high winds coming that were unexpected, or a big thunderstorm is coming, right?
mm,
Another option is we can speed the fans up even more to expel more air and expel more water, right? If there's high
mm,
degrees of storms and wind coming in where the water could get in,
mm,
right? It could make us so we change our filters quicker. So
mm,
now we might say, okay, we've always got filters in stock, say. So we say, all right, team, as soon as this happens, now of course we're measuring that stuff so we can see it, but it helps us prepare, and thus the impacts of that weather, being able to come out of it, it's faster, right? When you have a team that is focused on execution and react, just like y'all like,
mm,
when something happens, I bet you your team executes and reacts quicker than the
mm,
competition, right?
mm,
And in the name of entrepreneurship, that's what it's all about. It's
mm.
about knowing that things are going to happen, and being anti-fragile and resilient enough to
Sure.
to to solve those problems and get stronger. And that's what understanding the environment around us is, and being able to forecast that even 5 to 10 minutes ahead of time,
Mhm.
can have massive implications in our performance.
Awesome. Well, Deb, I really appreciate that answer and I appreciate your time today. So thank you very much for joining me. It was a pleasure to have you here, and I wish you the best of luck with the coming projects that you've got and over the next few years. And yeah, thanks a lot.
Thank you for what y'all do. Just get more green, more green, more green. Let's you
That's the
know
plan.
let's get it done. I appreciate it. Thanks.
Thanks, Deb. Now I'm excited to turn it over to Dan Slagan, who will be introducing our ESG and Climate Adaptation Award for our energy industry. Over to you, Dan.
The winner of our ESG and Climate Adaptation Award within the energy industry is Evergy.
Guess which arena I'm in?
How can we leverage this incredible power of sports, this voice that sports gives you, to truly make a difference in the world around us and in people's lives?